Firstly, power on the extension sockets behind the PC and then switch on the microscope power box using the switch on the front. Then start the PC. To add a sample to the stage and use an air objective, first press the button labelled Escape on the lower left-hand side of the microscope body to lower the stage. Now add your slide to the stage, ensuring it is cover slip upwards and held in place with a spring clip on the left. Using the manual stage control stick, move your sample until the area of the cover slip containing your sample is beneath the objective. Press the Escape button once more to move the stage back to the original position. Once it is in position, use the On button on the lower left of the microscope body to switch the bright field lamp on, and then use the focus knob and stage control to find your sample and focal plane, ensuring the oculars are set to the right interpupillary distance for your eyes. Once you have found a suitable field of view, switch off the bright field lamp by pressing the On switch again. If you want to view your sample via fluorescence, the epifluorescence shutter is controlled both by the shutter button on the lower right hand side of the microscope body and/or the QLED control on-off switch. Both need to be open to allow excitation light through to the objective. The fluorescence filter cubes can be rotated using the two buttons behind the right hand focus knob. Select one that is suitable for your sample and find your field of view. Once you have done so, switch off the fluorescence light to preserve your sample. Do so using either the shutter button on the microscope or the QLED on-off switch. If you wish to use an oil immersion objective, press Escape on the lower left-hand side of the microscope body to lower your sample. The objective turret can be rotated using the two buttons behind the left-hand focus knob. Select the immersion objective you wish to use. Here we have moved to the 100x. Now add a small drop of immersion oil directly below the objective using the supplied dropper bottle. Don't forget to replace the cap on the oil bottle. Return the stage to the focal plane by pressing the Escape button on the left of the microscope once more. Using either fluorescence or bright field, fine-tune the focus and field of view using the stage and focus controls. Once found, switch off the lamps to protect your sample.
So we'll start out by opening Elements by double-clicking on this icon here. It'll just take a moment. So we'll start off by introducing the layout of the Elements software. So up here we've got all of our lenses, and if you click on them you can change the lens. We've got Escape, so that's for lowering the stage or having it rise again. We've got the light path, so at the moment it's on binoculars, but if we move it to front then it should go to the camera. We've got the different lamps, we've got the filters, all the different filter cubes here. And then we've got for the light pad for the fluorescence imaging, we've got the three, we can adjust the intensity of the 3 LEDs. Over here we've got our different channels. So a channel is a setting for a filter, the intensity of the light that's associated with it, and it also has a default exposure time, and we'll come back to that later. So this is where we would set exposure, which is for how long the shutter stays open. And down here we have an acquisition tab, and we will be using the lambda, which is for setting up multiple channels. So if you want to image, for example, DAPI, FITSI and TRITSI all together, you would set that up with the lambda tab. And we also have Z series here for if you want to, if you've got a thick sample and you want to take images at multiple focal planes.
I've already found my sample using the eyepieces. I will now show you how to find your sample using the camera. Here are the eye channels for viewing a sample with the eyepieces, and below are the channels for looking at your sample with the camera. There are standard channels set up for bright field imaging using transmitted light, and fluorescence imaging using filters and for reflected light for DAPI, FITSI/GFP, TRITSI, Sci5 and Sci3, or fluorophores at similar wavelengths.
So I'm going to start by looking for my sample with the transmitted light. So I'm going to click on here. and I'm going to go live. And you can see it's quite bright, so I'm going to turn the lamp down. And now we can see the sample a little bit better. So we can see our sample here with a 10x. So this sample that we're looking at, this is tulip pollen. It's not the most exciting sample to use, but I use this for all my trainings, so I thought I may as well be consistent with our YouTube training. So I've got this little cluster here in the middle.
Now we will look at how to image fluorescent samples. If we switch over to Camera DAPI and then go live, you can see the faint shape of the pollen cluster. I'll just adjust the focus slightly with the focus wheel, but it's still pretty faint and dark. The DAPI channel is set up to use a 370nm LED. I can increase the brightness of the image by increasing the intensity of the light or by increasing the exposure. Button up here which is very helpful for telling you if your image is overexposed or underexposed. By default, overexposed pixels are shown as red and underexposed pixels are bright blue. If you select the arrow next to the button, you can change these default colours. The image here has some overexposure highlighted by the red patches. The camera that the NiE microscope uses is 12-bit. What this means is that it displays each pixel on a scale of 0 to 4096 increments of grey, from blackest black at 0 to whitest white at 4096, shown on this lookup table over here. You want to avoid having any pixels at these extremes. Overexposure is particularly difficult as large overexposed regions are not quantifiable in terms of brightness because they are essentially off the 12-bit scale. You'll also lose a lot of structural definition if large clusters of pixels are at their maximum. To rectify the overexposure shown here, I can either decrease the exposure or decrease the light intensity. If you want to increase the contrast of the image without changing the data being collected, you can adjust the scale of the lookup table. This can be helpful for visualizing and navigating dim samples before acquisition.
So that's looking at it with DAPI. I can then look at it with FITSI. So that looks quite nice. Again, I've got this up here to see if it's saturated, and it is not, so I can make it brighter. This is very low exposure time. What if I ramp that right up? So you can see there it's immediately gone massively overexposed. I'll put this down. There we go, so that's it with the GFP. So in order to set up a multi-channel image, we will go to one of the existing channels and we will duplicate it. So we'll call this one Camera DAPI 2. And we'll just do 2 channels for this, so the video is not too long. I'm going to duplicate this one.
I will optimize the light and exposure settings for each of the channels that we have created, following the steps that we went through earlier in the video. To save the light intensity and exposure time settings, click on the arrow on the channel button. The pink exclamation mark indicates when there are altered settings that need to be saved. Once the channel settings are saved, we can add it to the lambda by selecting the channel from the drop-down menu. So from here, we go to Camera, then we pick DAPI 2. Then we add the second channel, and here the software has already assumed that the GFP2 channel is the one we want. Now if we take an image, we can either save it automatically by ticking this box. If we untick the box, we can still save the image manually afterwards. But if we want to save it automatically, we can set the location by pressing Browse. We go to H drive, then to User Data, then you would make a file in your own name and put all of your acquisitions in there. I will put mine in here, that's me. So, to acquire our image, if we just click on the camera icon as we did before, it would just take an image with a single channel. We want to take an image with both of our lambda channels, so instead we will press Run down at the bottom here. The image shown here is an overlay of both channels. It looks turquoise where the autofluorescence of the pollen is being picked up under both the blue and green channels. If you've stained specific areas of your sample, this is where you would expect to see different sections highlighted by their different lookup tables. So you can look at both channels combined, or you can look at them both individually. To save the image manually, go to File, Save As, This PC, H drive, then User Data, and the file with your name on it as before. The files that you acquire with NIS elements are in the .nd2 format. We recommend that you always keep these files as they are the best way of retaining your metadata. If you need to export them to another format, that's fine, but always keep your .nd2 files. The metadata contains all of the information on how you went about acquiring your images, lenses, filters, exposure time, etc., which is very helpful for reproducibility. If you're interested in seeing your metadata, you can go to Image Properties, like so. If you have an uneven sample, you may struggle to get all of your sample in focus at the same time. You can overcome this by doing a Z-stack. A Z-stack takes images at multiple focal planes. This technique is also used for 3D imaging, but if you require an accurate 3D image, we would recommend that you switch to a confocal microscope instead. I'm just going to use one channel to demonstrate the Z-stack, so I'm unticking DAPI from Lambda. You can do Z-stacks with multiple channels, but the more you have, the longer it will take, and I want to keep this short for demonstration purposes. So we'll tick Z series here, then go live. We need to set the top and the bottom of our series. So we do that by moving the focal plane one way using the focus wheel. I'm going to say that this is the top. Focus the other way, set that as the bottom. It doesn't matter which way you go, as long as the software knows the upper and lower limits of the Z scale you're interested in, it will work it out. The software will recommend an optimum step size based on half the resolution of Z, which here is 0.9 microns between each step, giving a total of 47 steps for the depth that we've set with our top and bottom settings. You don't have to use the recommended number of steps. Often much less is fine for if you're just wanting a few focal planes rather than a full 3D image. So to acquire the stack, we hit the Run button again. You can see here the one channel we've set with Lambda, and then all of the different planes that we're acquiring through the Z series. Once the images are acquired, we can use the menu at the bottom to view each plane individually. Also a volume view at the top to view the stack in 3D. We can spin this around and zoom in. As you can see, this wouldn't be the most helpful image for measuring volumes or spatial differences between different areas on the Z-plane, as the widefield microscope takes in too much unfocused light to give a clear and accurate picture along the Z-axis. To shut everything down, make sure you saved everything you want to keep, then exit the software and remember to log out of the PC and shut it down if you're the last user booked on for the day.
To remove your sample, press the button labelled Escape on the lower left-hand side of the microscope body to lower the stage. Carefully remove your sample from the stage, then using the two buttons behind the left-hand focus knob, rotate the objective turret to the side to make the oil immersion lens easier to access for cleaning. For the oil immersion lens, take a single piece of lens tissue from the box and fold it in half. Use this to carefully wipe across the objective lens to remove excess oil. Using a fresh piece of lens tissue, wet it with alcohol from the supplied bottle and once again wipe the objective lens to remove any residual oil. Finally, take a clean, dry piece of lens tissue, fold it in half and wipe the lens to remove any alcohol residue. If there are any spillages on the microscope stage, also wipe these up. Now the system can be shut down. Ensure all images are saved and Elements is closed. Shut down the PC and switch off the microscope power using the switch on the front of the microscope power box to the left of the microscope. Lastly, once the PC has finished shutting down, the extension plug behind the PC can be switched off using the power button.